Understanding the assumptions of simple linear regression is crucial for building reliable models. Today, we'll explore these assumptions, how to evaluate them, the effects of breaking them, and practical application using Python. We'll cover the following learning objectives. Understand the assumptions of simple linear regression. Evaluate if a model satisfies these assumptions. Explore the impact of violated assumptions. Use Python to create and interpret residual plots. The first assumption is that a linear relationship exists between input x and output y. Residuals should be independent, have a mean of 0 and constant variance, and be approximately normally distributed. Evaluating linearity involves checking scatter plots for a linear pattern. For example, weight versus miles per gallon often shows a downward linear trend, which you can validate using regression lines. For residuals to be independent, they should appear random without patterns. Be cautious of dependencies like time or spatial data which can violate this assumption. Constant variance means residuals should spread evenly across all levels of x. A funnel or curved shape in a fitted versus residual plot indicates non-constant variance. Normality of residuals is assessed by how closely the residuals follow a normal distribution. QQ plots help by comparing observed residuals to theoretical normal quantiles, where points should align with the diagonal line. Here, we use Python code to evaluate these assumptions. One script creates a residual plot to assess linearity, constant variance, and independence. Another script generates a QQ plot for checking the normality of residuals. In summary, simple linear regression relies on assumptions of linearity, independence, constant variance, and normality of residuals. Violating these can lead to unreliable models. Python provides tools to check these assumptions, helping refine your models for better accuracy. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.